Pre-calculus students, this video is going to cover all of lesson 2.7, so it actually corresponds with lesson 1.8 in your textbook. We're going to cover inverse functions. So first of all, we start off with this function here, f of x plus 4, and if we let x be 1, 2, 3, or 4, then we can generate these ordered pairs for our function. So if x is 1, the y is 5, if x is 2, the y is 6, and so forth. If we want to interchange the x and the y coordinates, we would create what's called an inverse function. So that's what they say right here. If you interchange the coordinates, you're going to get its inverse. The notation for an inverse is f inverse right here. And so then you can write your inverse as a set of ordered pairs that are written backwards. You can also write it with the equation x minus 4. So if you think about taking x plus 4 and adding 4, you would be subtracting 4. It's true that the domain of f is equal to the range of f inverse, and then the other way around. All right, because you can swap the x's and y's, etc. When you take the composites, when you put f inverse inside of f, so remember here that f of x was x plus 4, and f inverse of x was x minus 4. If I take f inverse and I put it back in for x in the original function, I'll get x back. So if I take this and I put it in for x, then I'll be right here and I get x as a result. Likewise, if I do the composites the other way around, if I put f inverse in for x, then I'll have this situation, and again I get x back. And that is actually discussed right here. When you have inverses, if this is true and this is true, then f of g are inverses of each other. Okay, g is the inverse function, so this has to be true. And then again, it states that the domain of f must be equal to the range of f inverse, and the range of f must be equal to the domain of f inverse. On this slide, we just practiced. We found the inverse of 4x, so the inverse of multiplying by 4 is dividing by 4. We did the composites and showed that we got x. So verifying your composites means that you're going to put one function inside of the other and show that you get x back as an answer. When you graph inverses, functions that are inverses of each other can be reflected about the line y equals x. So that's this line right here. F of x is the gray line or curve, and f inverse is the black. And if I fold one curve over that line, I get the other curve. So we say the line y equals x is a line of symmetry for the function and its inverse. So on this slide, on this example, we practiced graphing two functions that were inverses of each other, and we put in the line y equals x right here, and you can see that it does act as a line of symmetry. Both of these lines were graphed with slope-intercept, so we graphed the y-intercept first, and then we followed through by graphing the slope. We talked about these practice problems, that if you're going to show algebraically and graphically, the algebraic side is showing that your composites equal x, and then of course the graphing looks just like what we did up here. The two functions on one grid with y equals x right in the middle. And then today we covered one-to-one functions. And if a function is one-to-one, it's going to pass the horizontal line test. And so any function that passes a horizontal line test will have an inverse. So we kind of diagrammed that all out with a tree diagram today. We have functions. categorized into two areas, not one-to-one and one-to-one. We made some notes here about functions. And then on the one-to-one side, we said that they have to pass the horizontal line test. No y's repeat, and therefore f has an inverse, and we say f inverse exists. Now, you have to be very careful. An entire parabola is a function, but it does not pass the horizontal line test. So it is not one-to-one, and you can't find the inverse. But if I only look at, say, this right side of my parabola, which is what I have here in the purple, and that's going to be denoted right there with that explicit domain. If I'm only looking at the right side of a parabola, then I will have an inverse. And so we went through the steps on how to find that inverse function. The first thing that we did was we took out f of x and we made it y. Then we substituted, we swapped, we traded x for y. So whatever was y became x and whatever was x became y. And then we solve for y. Finally, from here to here, you're just changing the notation. We graphed it. That is the square root function shifted left 2. So that's the one in orange. So in purple, I have f, and in orange, I have f inverse. And again, this is the line y equals x. For this one, we went through the whole process. We were given the black curve, which is x to the third minus 1. And we decided that it does have an inverse because it is one-to-one. It does pass the horizontal line test. And so we went through the motions again on finding the inverse, and that's what these steps are right here. So there's your steps. This is the end result. We made some ordered pairs for f of x. Those are the points right here that are graphed. And if you take those points in your xy table and you turn them around, -2, -1 is this point right here. 0, -1 is this point right here. And I'm sorry, -2, -1 is here. -1, 0 is here. And 0, 1 is here. If you graph those, you'll have your inverse function. Then we went here today. This horizontal line is just showing you that the parabola fails the one-to-one test. It fails the horizontal line test, so it is not one-to-one and does not have an inverse. And the last thing we did today was this one right here. So we just found the inverse of this function. So we practiced switching f of x to y, swapping x and y around, and then solving for y. So to get from this step to this step, I multiplied both sides of the equation by 3y plus 2. Then I distributed, and then on the black step, this one right here, I took anything that had y and I put it on the left. So this term came over here. And because 2x did not have y with it, I moved it to the right. So I collected the terms together that have y. From here to here, I factored out the y. And then I divided by 3x plus 1 on both sides. And the end result is your inverse. And that is actually where we stopped our notes today. Hope to see you guys back in class soon.